The running time T of 200 family movies are recorded in the following table. Write down the mid-interval value of t greater than or equal to 70 less than 80. Mid-interval value equals 70 plus 80 over 2. So we get 75. Calculate an estimate of the mean running time of the 200 movies. First of all, we need to figure out mid-interval value. 75. 80 plus 85 over 2, 82.5. 87.5, 92.5, 100. Then we need to put this into calculator to figure out the mean. Since this is a frequency, so only have one variable, we need to go to one variable stats. Click on 1. Then no. We will go to 4. Name column 1 as P. Then column B as a frequency. So FR. After you put in all the values, click on an empty cell. Menu. 4. Statistics. 1. Stats calculations. This is one variable stats because the second column is a frequency. For one variable stats, number of leads is always 1. Then enter. Right arrow button to get P as the X1 list. For frequency list, it's a FR. Then enter. So we get this X bar, which is mean is 88.15. Since this is 2 marks, so we need to show the work. X bar equals 75 times 11, 82.5 times 51, 87.5 times 68, 92.5 times 47, 100 times 23. All over, frequency, add all this together, equals 200, equals 88.15. This table is used to create the following cumulative frequency graph. Use the cumulative frequency curve to estimate the interquartile range. Interquartile range IQR equals Q3 minus Q1. Q3 is 75%. So 75% times cumulative frequency total is 200 equals 150. Get 150. Then going down. Then you need to check the unit for running time. From 70 to 75, we count how many small units here. 75 minus 70 over 10 equals 0.5. So 90 plus, we have 3 units of 0.5. 90 plus 3 times 0.5 is 91.5. For Q1, the first quartile equals 25%. So 25% times the total number 200 equals 50. So get this 50, draw this horizontal line, then going down. 80 plus, altogether is 8. Each is 0.5, so we get 84 equals 91.5 minus 84 equals 7.5. Starfield is a movie in the data set, and its running time is 100 minutes. Use your answer to part B to estimate whether Starfield's running time is an outlier for this data. Justify your answer. We have a lower outlier. We will use the closest quartile minus 1.5 IQR. Higher outlier. Closest quartile is Q3. Add 1.5 IQR. We will find a higher outlier equals Q3 is 91.5 plus 1.5 times 7.5 equals 102.75. Since 100 less than 102.75, it's not an outlier. It's believed that the running times of family movies follow a normal distribution with a mean 88 minutes and a standard deviation 6.75 minutes. We can write down this normal distribution n with 88 6.75 squared. It's decided to perform a chi-square goodness of fit test on the data to determine whether this sample of 200 movies could have plausibly been drawn from an underlying distribution n88 6.75 squared. Write down the null and alternative hypotheses for this test. We want to test the running times of family movies follow a normal distribution with mean 88 minutes and a standard deviation 6.75 minutes. This is HO. H1 will be opposite. H1, the running times of family movies don't follow a normal distribution, n88 6.75 squared. As part of test, the following table is created. Find the value of A and the value of B. We will work out this expected frequency. We will work out this expected frequency based on the assumption HO is true. So we assume observed frequency follows a normal distribution with 88 as the mean, 6.75 as the standard deviation. So this A equals probability times N. N is given 200 movies. So N equals 200. Probability, we will use normal CDF times 200 equals 85 lower bound, 90 is the upper bound. Go to this calculator, scratch pad, control menu, clear the history. Go to menu 5, 2, normal CDF, 85, upper bound 90, mean 88, standard deviation 6.75, enter. Then times 200, 57.6, 85, 90, 88, 6.75. B equals, we will work out B by subtraction from 200. 200 minus 23.6 minus 42.1 minus 57.6 minus 46.7 equals 30. Hence, perform the test to a 5% significance level, clearly stating the conclusion in context. We will put observed frequency and expected frequency to the spreadsheet. Let's go to calculator. On 1, no, 4, spreadsheet, P, here is a Q. Type in the observed frequency and expected frequency separately. Go to menu, 4, statistics, 4, stat tests, 7, chi-square GOF, right arrow button, get P for observed list. Expected list will be Q. DF, we have 5 data, 5 minus 1 is 4. Then enter. Chi-squared equals 12.1. P-value 0.0165. DF equals 4. Chi-squared equals 12.1. P-value equals 0.0165. DF equals 4. We can draw the conclusion now. P-value 0.0165. Alpha equals 0.05. Compare which one is greater. This is less than. We know please reject HO. P-value less than alpha. Reject HO. We got 0.0165 or less than 0.05. Reject HO. So we write down H1. H1, the running times of family movies don't follow a normal distribution. N88, 6.75 squared. The running times of family movies do not follow a normal distribution, with 88 as the mean, 6.75 as the standard deviation.